This container home cost $85,000 to build. 6 months later, the foundation failed. The repair cost, $47,000. The owner thought they'd saved money by skipping the engineering step. Instead, they lost more than half their investment. I'm a structural engineer specializing in container construction, and today I'm going to share the 3 foundation rules that will prevent your container home from sinking, tilting, or worse, collapsing. These aren't opinions, they're engineering principles backed by physics, soil mechanics, and decades of structural data. By the end of this video, you'll understand exactly why most DIY foundations fail, which foundation type you actually need, and the one critical measurement that determines whether your home will stand for 5 years or 50 years. Let's get into it. Never assume your soil can handle the load without testing. Here's why. A standard 40-foot shipping container weighs 8,000 pounds empty. Add insulation, framing, drywall, appliances, furniture, and occupants, and you're looking at 15,000 to 20,000 pounds of total load. That's 10 tons of pressure concentrated on just 4 corner points. Now, soil isn't uniform. Sandy soil can bear 2,000 to 3,000 pounds per square foot. Clay soil, only 1,500 pounds per square foot. Expansive clay, the type that swells when wet, can drop to under 1,000 pounds per square foot. If you place a 20,000-pound container on 4 concrete blocks in clay soil without calculating bearing capacity, you're gambling. One corner might sink 2 inches, another 4 inches. That differential settlement creates stress fractures in the container's steel frame, and steel doesn't bend back. Let me give you a real-world example. I consulted on a project in Texas where the owner used pier blocks on clay soil. No geotechnical report. Within 8 months, one corner had sunk 6 inches. Doors wouldn't close, windows cracked. The fix required excavation, soil stabilization, and helical piers. $38,000 in repairs. So what must you do? Step 1. Get a geotechnical report. This costs $500 to $1,500 and tells you your soil's bearing capacity, water table depth, and expansion potential. This is not optional. This is engineering. Step 2. Calculate your total load. That's empty container weight plus modifications plus live load. Live load means furniture and people. For residential containers, add 40 pounds per square foot for live load. For multi-story construction, multiply by the number of stacked units. Step 3. Match your foundation to your soil. If your soil can only handle 1,200 pounds per square foot, you need a larger foundation footprint to spread the load. We'll cover specific foundation types in Rule 2. Bottom line, soil analysis isn't a luxury. It's physics. Skip this step, and you're building on hope, not engineering. Now that you understand load and soil capacity, let's talk about the 3 foundation systems that actually work for container homes. I'm not covering concrete blocks or railroad ties. Those aren't foundations, they're guesses. Foundation option 1, isolated footings, also known as pier foundations. Isolated footings are reinforced concrete pads placed under each corner of the container. Each footing is typically 24 to 36 inches square and 12 to 18 inches deep with rebar reinforcement. When should you use isolated footings? First, when you have stable soil with good bearing capacity, at least 2,000 pounds per square foot. Second, for single-story containers, or 2 containers side by side. Third, on level terrain with minimal frost heave risk. Here's the engineering principle. The footing spreads the point load over a larger area, reducing pressure on the soil. If your container weighs 20,000 pounds and you have 4 footings, each footing carries 5,000 pounds. A 30-inch by 30-inch footing has 900 square inches of contact area. That's only 5.5 pounds per square inch, well within safe limits for most soils. When should you not use isolated footings? First, Never use them on expansive clay soil that swells and contracts with moisture. Second, avoid them in flood-prone areas where footings can wash out. Third, never use them for multi-story stacking because the differential settlement risk is too high. Foundation option 2, raft foundation, also called a monolithic slab. A raft foundation is a continuous reinforced concrete slab that supports the entire container footprint. Think of it as a giant concrete platform, typically 6 to 8 inches thick with a rebar grid reinforcement. When should you use a raft foundation? First, when you have poor or variable soil conditions like clay, fill dirt, or mixed soil types. Second, for multi-container configurations where you're joining 3 or more containers. Third, in areas with high water tables or flood risk. Fourth, for multi-story stacking. Here's the engineering principle. The raft distributes the load across the entire slab area, minimizing differential settlement. If one section of soil settles, the rigid slab forces the entire structure to settle uniformly, like a boat floating on water. This prevents the corner-to-corner tilting that destroys containers. Yes, a raft costs more upfront, typically $8,000 to $15,000 for a single 40-foot container. But compare that to a $40,000 repair bill from differential settlement. The slab also provides a built-in finished floor, eliminating the need for additional flooring structure. One critical detail: the slab must extend at least 12 inches beyond the container perimeter on all sides. This provides edge support and prevents erosion from undermining the foundation. Foundation option 3, helical piles, also known as deep foundations. Helical piles are steel shafts with helical plates, like giant screws, that are mechanically driven into the ground until they reach load-bearing strata. These are the gold standard for problem soils. When should you use helical piles? First, when you have weak or unstable surface soil, like soft clay, peat, or fill. Second, in areas with high water tables or wetlands. Third, in flood zones, where piles elevate the container above flood level. Fourth, on hillside or sloped terrain. Fifth, in coastal areas with sandy soil and storm surge risk. Here's the engineering principle. Helical piles bypass weak surface soil entirely and anchor into competent bearing strata 10 to 30 feet deep. Each pile is load tested during installation, so you know exactly how much weight it can support. There's no guessing. The downside? Cost. Helical piles run $2,000 to $5,000 per container, depending on depth and soil conditions. But if your geotechnical report shows weak soil, piles aren't optional. They're the only engineered solution that works. I've seen DIYers try to save money with surface footings and soft soil. Every single one failed. Don't be that person. Rule 3 is the most commonly ignored rule, and it causes more failures than any other mistake. Your foundation must be perfectly level. Not close enough, not we'll shim it, perfectly level. Shipping containers are designed to bear loads vertically through their corner posts. When you tilt a container even 2 degrees, that's less than half an inch over 20 feet, you create lateral stress on the corrugated walls. Those walls aren't designed for lateral loads, they'll buckle. The tolerance for container foundations is 1/4 inch over the entire length. For a 40-foot container, that means the difference between the highest and lowest corner cannot exceed 1/4 inch. That's about the thickness of a pencil. How do you achieve this? Use a laser level during foundation construction, not a bubble level. Those aren't precise enough. A rotary laser level will give you accuracy within 1/16 inch over 100 feet. If your foundation is off by more than 1/4 inch, don't place the container. Rework the foundation. I know that sounds extreme, but consider the alternative: a container that won't accept modifications, doors that jam, and structural stress that compounds over time. Now let's talk about what happens after your container is in place. Water is the enemy of steel. Container homes fail not because the steel rusts through, that takes decades, but because water undermines the foundation. Here's what water does. First, it corrodes the bottom rails of your container. Even with paint or coating, moisture trapped under the container accelerates rust. Second, water erodes the soil under your foundation. That soil compaction you relied on? Gone. Third, in freezing climates, water under the foundation freezes and expands. This is called frost heave, and it lifts one section of your foundation while leaving another in place. The drainage solution is a three-part system. Part 1, site grading. The ground around the container must slope away from the foundation at a minimum grade of 2%. That's 1/4 inch of drop per foot. For a 40-foot container, the ground 10 feet away from the container should be 2.5 inches lower than the foundation. Part 2, French drain perimeter. Install a French drain, that's a gravel-filled trench with perforated pipe, along the perimeter of your foundation. This captures water before it reaches the container and channels it away to a daylight outlet or sump. The trench should be 12 inches deep and 12 inches wide, with the pipe sloped at 1% minimum grade. Part 3, vapor barrier under container. Before placing the container, lay a 6 ml polyethylene vapor barrier over the foundation. This prevents ground moisture from wicking up into the container floor. It costs $50 and takes 20 minutes. Skip this, and you'll have condensation and rust within a year. If you're building in a coastal area or anywhere with a high water table, you need to elevate the container at least 18 inches above grade. This allows air circulation under the container, prevents saltwater contact with the steel, and keeps you out of the flood zone insurance surcharge. I've inspected containers in Florida where the owner placed them directly on grade. Within 3 years, the bottom rails were perforated with rust. The fix? Jack up the container, replace the bottom rails, and install helical piles. Cost? $28,000. The elevation system would have cost $3,000. Let's recap the 3 foundation rules that will keep your container home standing for decades. Rule 1. Get a geotechnical report and calculate your load. Don't guess. Soil analysis costs $500 to $1,500. Foundation failure repairs cost $30,000 to $60,000. The math isn't complicated. Rule 2. Choose the right foundation type for your soil. Isolated footings for stable soil, raft foundations for poor or variable soil in multi-container builds, helical piles for weak soil, flood zones, and hillsides. Match the foundation to the engineering requirements, not to your budget. Rule 3. Level your foundation to within 1/4 inch and install proper drainage. Use a laser level. Grade the site away from the container. Install a French drain. Lay a vapor barrier. These aren't optional steps, they're engineering fundamentals. Follow these 3 rules and your container home will outlast a stick-built house. Ignore them and you're building on borrowed time. If this video saved you from making a $50,000 mistake, do me a favor, hit that subscribe button and turn on notifications. This channel exists to give you the engineering knowledge that prevents catastrophic failures. Next week, I'm breaking down the 3 structural modifications that will collapse your container and the engineering solutions that make them safe. You don't want to miss that video. It could literally save your life. Drop a comment below. What's your biggest foundation concern? Soil type? Multi-story stacking? Flood zones? I read every comment, and I'll answer your specific situation. Thanks for watching. Build smart, build safe, and remember, engineering isn't expensive. Failure is.